Hey everybody, in this video, I'm going to show you how to use the ZWO AM5N mount. This is going to be the standard AM5 moving forward, so I wanted to make sure I had an updated tutorial. If you want to see the differences between the new version and the old version, you can watch virtually any other ASIAir channel on YouTube. They've all done a great job explaining those differences, but I want to focus on how to actually use the new mount. Alright, let's start off and make sure we have all the same components. Of course, we have the carrying case, we have the tripod, we've got the leg lock, and then the attachment screw. You might also have this piece of paper which shows the testing from the factory, and that is one of the benefits of the new version, is that it should have a lower periodic error, which means you get better guiding and better tracking. As we open up the carrying case, we can see, of course, the AM5 right here in the middle, along with a few different cables and the hand controller. There's even a slot now for the counterweight rod, which is really nice because if you end up using a larger telescope, you will want to purchase that optional counterweight rod. And I'm actually just using some SkyGuider Pro weights, which fit on there perfectly, but you can always find some other weights that are a bit larger and heavier if you need them. The first USB cable that we have goes from USB-C to USB-A. This will let you connect from the AM5 to your ASIAir if you intend to use one. And the cool thing is you can actually plug this right into the dovetail saddle on the top of the AM5, which should help to prevent the cables from getting snagged as you move across the night sky. We also have the original USB cable that you could use, although again you might run into issues where things start to get snagged in weird orientations, but it's good that they still include this if you want to use it. We've also got the hand controller for the AM5, and you don't really need to use this, frankly, but it could come in handy for troubleshooting. And to be clear, this does generate the Wi-Fi signal for the AM5, so it does need to be plugged in if you want to connect via Wi-Fi. And to connect the two together, you just use this little phone-looking cable. One end goes into the hand controller, the other end into the mount. Alright, we've covered what's in the box. Now let's talk about how to attach the AM5 to your tripod. Unfortunately, this will not just go right on the tripod. You have to do one additional step. As you can see here on my original AM5 mount, there was a silver bracket that I attached to the bottom of the unit, and this is what allows us to attach it to the tripod ultimately. So you want to go and find that silver bracket, get an Allen key, and then attach it to the bottom of your AM5N. Because I'm using a demo unit that was sent to me by ZWO, they did not include the tripod, so I actually have to take my stuff off the old one and put it on the new one, which you can see here in the video. Okay, at this point, we should have our bracket attached, and now if we were to drop this right into the tripod, it should go in and stay secure. I would recommend that you turn the AM5, that way it lines up with one of the tripod legs though, because if it's off at another angle, there's a chance it will make it more unstable, and if you have a very heavy telescope, the whole thing could theoretically tip over. With your AM5 lined up, all you have to do is find this screw on the side of the tripod and tighten it down. At that point, it should be nice and secure. However, if you want to be even more secure, then you can take the leg lock, the other screw, and then the end cap and put it all together, like you see here. Before we move on, I should mention that if you're using a long telescope, you might want to invest in a Pier mount extension. ZWO has two different options available. One has a higher payload capacity, and what this will do is actually raise the AM5 up away from the tripod legs, giving you more clearance if you have a long telescope. On the underside of the AM5, you'll see this screw, which you can undo, and then at that point, if you purchase the optional counterweight rod for about $40, you can screw that right in. However, the payload capacity for the AM5N is 33 pounds without a counterweight. Therefore, if you're using anything, I would say like 25 pounds or lighter, don't worry about the counterweight unless you really want to. But if you are going to be using anything 30 pounds and up, then you'll definitely want to get that counterweight rod and also get a counterweight or two to go along with that. As I mentioned earlier, I'm just using some old SkyGuider Pro counterweights, and those fit on here just fine. But one of the issues with the AM5 is that because it's a harmonic mount, there's no RA or deck clutch, which you might be familiar with a more traditional go-to mount. Therefore, you'll never really know if things are balanced because you can't do it yourself. So you're just kind of guessing. We will talk about balancing more in a few minutes though. Moving up to the top of the AM5, we have our series of inputs along with the new Bluetooth connectivity. We also have the old-fashioned USB cable if you want to plug that in, but as I said earlier, you're probably better off using the USB-C on the declination bracket. There's also an auto guide port. This is for your ST4 cable, but if you have modern gear, you really shouldn't be messing with the auto guider port on here because it uses the older, antiquated protocols which are not nearly as good as the new ones. And it's a good thing they blocked off this port so you don't get confused. Then we have the hand controller port, designated HC. This is where you'll plug in that phone cable if you want to use the hand controller, but you really don't need to worry about it if you have the ASIAir. Then we have the power input, DC 12 volts at 5 amps. You can either use the AC adapter that they often recommend. I like doing a straight DC connection though. This is where you get like a cigarette lighter cable and plug it in your battery. That works better for me. Here's a look at the dovetail saddle or declination plate, whatever you want to call it. We have actually a power output, so don't get confused. The one on the other side is the power input. This is the power output. And you can use this to power your ASIAir if you want to. That's normally what I do. The Type-C port, this is where you can connect that new USB cable from here to your ASIAir, which should help to prevent any sort of cable snags. Moving down, we have the Azimuth adjustment screws. This will turn the mount left to right during your polar alignment. The problem though is you only have about 6 degrees of movement, and once that middle rod reaches the end, you're kind of stuck. You can't go any further. If this happens to you during the polar alignment, you could pick up the whole tripod and turn it slightly, or you could even just loosen that screw on the side of the tripod, rotate the AM5 and then tighten it back down. That's probably the easiest way to go about it. Either way, once you've gotten a perfect polar alignment, make sure you turn one screw one way, one screw the other way at the same time. That tightens them down and prevents them from moving. Next up, we have the altitude adjustment, and those numbers there correspond to your current latitude. In my case, I'm around 43 degrees north, so that's what I'd put in. And you might want to loosen those 2 screws on the side of the AM5. That'll make turning the altitude easier. Then once you've got everything dialed in, you can just tighten down those side screws again, and you're all set. Before we continue on, I wanted to note 2 important differences between the AM5N and the original AM5 model. The first is that the N does not have a bubble level anymore, which I find kind of odd. This seems like a simple, cheap addition that makes things much easier, especially if you're shooting in the grass like I am. But for whatever reason, the AM5N no longer has this. I suppose you could always probably buy a bubble level and like tape it on here or get some sticky glue. It might not be a bad idea. Another important difference is that ZWO has removed that little dovetail plate and the power output from the side of the AM5. Most likely because they're afraid of cables getting ripped out, among other issues. And when I asked ZWO how we should mount our ASIAirs moving forward, they said you can always attach it to the guide scope bracket of your telescope if you have one, or even just attach it to the dovetail plate of your telescope if that's an option. And we'll be taking a look at some of these options later on in the video. Alright, we've covered all the basics of the AM5. Let's get this thing powered up and turned on and see how it works. Like I said, I am using a 12 volt DC power cable. I'm plugging that in directly to my Jackery battery. This works well for me, but I have heard from multiple students that they've had problems with the Jackery batteries. Therefore, you might want to do your own research and see if you can find a more compatible option in terms of your battery power. I would caution you away from the AC adapter though, because I've seen where that causes all kinds of weird little glitches throughout the night. I think a straight DC to DC connection not only gives you a longer battery life, but reduces some of those weird problems. Next, we'll take our power cable, plug that into the top of the AM5, that is the power input. Make sure you turn on your battery if you haven't done so already. And then at that point, you can click on the power button on this side of the AM5. You should hear a loud beep. That means you're good to go. Because this is our first time using the AM5N, I want to make sure the firmware is up to date and we go through the basics. So I'm going to grab my hand controller, plug that into the mount using that little phone cable. Then once that hand controller is turned on and connected, you can connect to the Wi-Fi network on your phone using the credentials and the network name that are seen here on the back of the hand controller. Although if you want to try the Bluetooth connection, that might actually work a little bit better and you don't have to worry about the Wi-Fi in that case. But for whatever reason, my phone could not pair with the Bluetooth to the AM5. I'm not sure what was going wrong, but if that happens to you, just use the Wi-Fi and that would be fine. I'd recommend you use that hand controller and the joystick to just move the mount around a bit get a feel for it, but don't attach any telescope or camera just yet. And if you want to go back to the original home position, just press and hold on that arrow button for about 3 seconds, and it'll go back to the original orientation. Finally, let's get the app for the AM5. It's called Sky Atlas, but you might not be able to find it, so if you just search for ZWO, it should be one of the first hits. It has that Big Dipper icon, that's the one you're looking for. When you have the Sky Atlas app installed, the hand controller plugged in and everything turned on, then we'll go into our phone settings, go to the Wi-Fi settings, and look for the AMH Wi-Fi network. The default password is always 12345678, and if you're not sure, just check the back of the hand controller, it should be listed on there. You'll likely get a warning that says, "This network has no internet access, stay connected." Be sure to check on the box that says, "Don't ask again," and hit yes. Otherwise, there's a good chance it will drop off that Wi-Fi network and you won't stay connected. We are now connected to the AM5 via the hand controller. Let's find that Sky Atlas app. In my case, it's called Stargazing, so that's why I said it's kind of confusing, but just look for the Big Dipper icon. And from here, we can control the mount using the arrows on the right. We can also adjust the speed of the movement, or you can use the hand controller, whatever you're more comfortable with. In the lower left corner, we have a button, and this brings us to the settings menu for the app. You can adjust the visibility of things like the meridian, the equator, the ground, whatever you want to do. There's also the ASI mount settings. This is where you can turn on or off the tracking, turn off the beep if it's too loud when you turn on the AM5. You can change the Wi-Fi network name, although I don't recommend doing that. There's a heavy duty mode and a few other features. But to be honest, most people are never actually going to use this app because if you have the ASIAir, that's going to control everything from the AM5 to your camera to the guiding and more. So I'm just talking about the app today to be thorough, but realistically I would never actually use this unless I had to do some basic troubleshooting of the AM5. With that in mind, we're going to head back outside, we'll grab our telescope and camera, we'll attach it safely to the AM5, we'll talk about cables and the ASIAir. I'll be using the William Optics SpaceCat 61 for this video, along with the ASI 2600MC Duo camera. And I can just slide these right onto the dovetail plate and tighten everything down. And when you're doing this, make sure the telescope is actually fitting inside the grooves, because there's a chance that it's not, and if you were to let go, the whole thing gets slide to the ground and crash. I will always double check that everything is securely attached before I let go. Our next goal is to attach the ASIAir, and this can either be very easy or very difficult depending on your configuration. I'm going to keep this as simple as possible by attaching my ASIAir to the guide scope bracket on the SpaceCat 61. Of course, if you're using an auto guider and guide scope currently in that bracket, then this will not be feasible for you. And what you would want to do is spend some time researching this online and find an alternate solution. With the ASIAir attached, the next step is to balance the telescope on the declination axis. I'm using a fairly large and heavy camera for this video, and that will affect the balance because it's making everything back heavy. Now there's no real way to know where the balance point is, we're just kind of guessing, so do the best you can. Fundamentally though, what we want to do is loosen those screws with a firm hand on the telescope and then either slide it forwards or backwards to find that balance point. Remember, you're just kind of guessing, but get it as close as you think you can get it. Tighten down the screws, and that's the basics of our balance. Finally, we'll attach the cables. I'll start with the USB-C cable, plug that from the bottom of the declination bracket, or the dovetail plate, and put the other end into the ASIAir. You can put it into any of the 4 USB ports. Then we'll grab a power cable. I'm using a right-angled adapter, and a fairly short cable at that. I'll plug one end into the declination bracket, and then the other end will go into the ASIAir's power input. This allows us to power the ASIAir using the AM5, which is ultimately being powered by my Jackery battery through that 12-volt cable. Let's move on to the camera. I'll take a USB 3.0 cable and connect that from the back of the camera to one of the 4 USB ports on the ASIAir. And if you have a 3.0 port, that's probably your best bet. Then we'll take a power cable and plug that from the back of the camera into one of the 4 power outputs on the ASIAir. That's all there is to it. You should now have all of your cables connected. Although if you have an auto guider and guide scope, you'd want to connect that as well to the ASIAir. The only problem is my cables are a mess, and I should really do better about tidying these up. What I'd like everybody to do is to test that their cables aren't going to get snagged or caught on any of the screws on the AM5, because it's better to test this out during the day, or we're not necessarily going to risk breaking everything in the middle of the night. For this test, you can either use the hand controller, as I showed you earlier, or you can go into the ASIAir and use the arrows to control the mount. I want you to move it in all kinds of crazy directions just to verify that the cables aren't going to get caught or wrapped around the AM5. As you can see here, even though my cable management is non-existent, it's not a problem. My cables aren't in any danger of getting caught on a screw. If you are having problems though, then you might want to invest in those 3D printed little cable adapters. Those could help to keep you organized, or even just get some twist ties and pick up the slack. Now that you've confirmed that your cables are all looking good, you can put the mount back to the home position. That'll make it easier to pick up and go on the following night. Alright, I've shown you how to set up your new AM5 during the day. Let's go through and do the full process at night with the ASIAir. The first thing you want to do is take your mount outside, attach the telescope and camera, connect all the cables, and then make sure the mount is roughly lined towards Polaris. And I generally just look over the top of the telescope and confirm that Polaris is right over the top of the guide scope bracket. You'll also want to verify that the latitude is set correctly on the base, and then at that point, you've done your rough polar alignment. From here, we'll turn on the power to everything, take our phone or iPad, and then connect to the Wi-Fi network of the ASIAir. Once you're connected, you can start up the ASIAir app, and then from here, you'll choose your mount as ZWO AM5, enter your main scope and guide scope focal length. Because I'm using the new 2600 Air, which has an auto guider sensor and a main camera sensor in the same camera, I have the same focal length, 300 millimeters, with my SpaceCat 61 telescope. Before you click on enter, you'll want to double check and confirm that your latitude and longitude are set correctly. And if the auto update is not working, then you can always manually enter the coordinates. That would be fine. That's all there is to it for the initial setup. We'll click on enter. And at this point, we have about 5 main goals. The first is to focus our telescope. The second is to do the polar alignment. The third is to find the object that we want to photograph and center it up. The fourth is to begin the guiding. And then the fifth is to start taking photos. For step number 1, we'll be here in the preview window, and we'll start taking some test photos, usually 3 seconds long, should be fine. To make things easier, you'll want to use a Bahtinov mask, and that will give you a diffraction spike, which shows you if your star is actually sharp or not. Every time you make a focusing adjustment, you'll want to take another photo and see if the stars get better or worse, and make sure you zoom in all the way to make this easier. If you can't see any stars at all, you can either increase the exposure time or go into the main camera settings and increase the gain. Focusing will take a while, depending on your telescope, your eyesight, and how many bright stars are actually visible in your field of view. But I don't want you to get too obsessed with getting the stars perfectly focused, especially at this point in the workflow, because the focus will likely shift between now and the time we're ready to shoot, because the temperature is cooling, among other factors. So just get the focus fairly close, and then at that point you can remove the Bahtinov mask, and we can move on with the workflow. But you have to remember to remove that Bahtinov mask. After a few minutes of trial and error, I got my stars nice and sharp, I removed the Bahtinov mask, and now we can begin step number 2, which is the polar alignment. For this, we'll click on preview and change to PA for polar align. Before you click on that play button, make sure to change the exposure to 3 seconds or whatever exposure length you've been using to focus. That'll work fine. Then we'll click on the play button, and everything's pretty much automated. It's going to take its first photo, then it will look at the stars and plate solve the image to understand what it's looking at. If it can understand what it's looking at, then it will rotate the mount down about 60 degrees and take a second photo. So you just want to click on next to continue on. If you encounter errors during this step, it's probably because you accidentally left the Bahtinov mask on, there's some clouds blowing through, or there's trees or something in the way. Basically, there's some sort of obstruction that's confusing your mount and it can't understand what it's looking at. Most of the time though, this shouldn't be an issue. And in my case, we're looking good. So I'll click on Let's Go. Over on the right, we have an up arrow and a right arrow, along with some numbers. What that means is I need to move the mount upwards 2 degrees, 17 minutes, 31 seconds, and to the right, 1 degree, 55 minutes, 3 seconds. I'd recommend you start off with one thing at a time, and since my up is the worst, I'll focus on my altitude adjustment. So I'll go down to the base, turn that altitude knob one way or the other until I can see it going up, and when I think I've got it fairly close, I'll click on refresh, and it will take another photo. Then it will update the total error. That's already a lot better. I'm down to 51 minutes of error for my altitude. So I'll go ahead and make some more adjustments and then click on refresh. It looks like I overshot it that time, so I'm going to go down just the slightest amount and try again, but you get the idea. Just focus on one axis at a time, and then when you've got the total error, I would say 1 minute or less, you're good to go. With my altitude looking good, I'm going to focus on the azimuth next. This is where we turn those 2 screws in the same direction at the same time to rotate the mount, and then we'll click on refresh. Don't forget, if you run out of room and you can't turn the screws any further, you could loosen that little knob on the side of the tripod and then actually rotate the mount slightly one way or the other, and then tighten back down that screw. And the great thing is with the AM5, the adjustments are so precise, it makes this much easier. If you've ever had to use an old SkyGuider Pro or anything like that, and you know how frustrating it is to do a polar alignment, you're going to love these new adjustment screws. When you get the smiley face icon and it says finish, you're free to stop and continue on. But because the AM5 allows for such precise adjustments, I'm going to try to get this as low as possible. And there we go. A total error of just 43 seconds. That's probably one of the best polar alignments I've ever done. So we're looking good. I'll click on finish. And that's step number 2 completed. We've done our polar alignment. You have to make sure though that nothing moves from here on out. If the tripod shifts slightly, if your mount happens to rotate a bit, all these things will mess up your polar alignment and you'll have to redo this entire step. If you're ready though, we'll click back on PA and change to preview. Step number 3 is to find our target and get it centered up. For this, we'll click on the Big Dipper icon in the lower left corner. This brings us to the Sky Atlas. Here in the Sky Atlas, you can see that we're currently aimed up towards Polaris, and we can either use this map manually to find our target, or thanks to some new updates, you can actually just search for the target, whatever you want to photograph. So I'll click on Objects, and by default, that brings us into Tonight's Best. So you could scroll down through here and see if anything looks interesting to you. If so, just click on it and hit Go To. It's that simple. I actually prefer to find my targets manually most of the time, so I'm actually going to back out of here and then just use the map to find something to photograph. The moon is out tonight, and that's adding a lot of light pollution to the night sky. So I need to find something up overhead to the north that has a lot of H-alpha. I've got the Elephant's Trunk Nebula here. That might be a good target. So once I get the composition looking halfway decent and centered up, then I'll click on the Go To button in the lower right. And in just a few seconds, the mount will begin moving and try to do its best to get the same composition. It will take a few test photos just to verify that it is centered up, so this will take a minute, but when it's complete, that's all there is to it. We've found our target, and we can back out of this menu. That completes step number 3, but I always recommend you take another test photo just to verify that you like the composition. So I'm going to take a 60-second long photo. You might even want to do a 2 or 3 minute long photo, and then we'll pick back up when that's done. All right, welcome back. Here's a look at the Elephant's Trunk Nebula, and I gotta say, it doesn't look very good. I can barely see it. That's for 2 main reasons. The first is that it's not even actually dark yet. It's only 10 o'clock, and true darkness doesn't come until about 10:30. In addition to that, as I said, the moon is out, and that's also washing out the nebula. But when this first photo completes, I want you to click on that Solve button on the left. This will plate solve the image, and then you could click on Sync Mount. This will confirm that both you and the mount know what you're looking at. You can even click on the Detect button to give you an idea of how big your stars are and how blurry they might be, and the Annotate button as well. This will actually list out the targets in your field of view. With the plate solve complete, you can go back to the Sky Atlas menu and take another look at your composition. If you find that things are not quite perfect, use your fingers to adjust the composition slightly and then hit Go To once again. Let's move on to step number 4, which is to begin guiding. For this, we'll click on the Guide button there on the left, And then when that brings up the graph, we'll just click on the graph. That brings us into the guiding interface, which is different from the previous interface that we've been working out of. Before you do anything else, I'd recommend you change the exposure from 1 second to 3 seconds. This seems to work well for the guiding exposure. Then from there, just read what it says in the background. Step number 1 is to tap the begin looping arrows. This will prompt your auto guider camera to take photos. And provided the stars look good, all you have to do at that point is click on the begin guiding crosshair button and everything else is automated. Unfortunately, it looks like my stars are very blurry and I can barely even see them. That means we need to focus the auto guider. And you can do this on the 2600 Air or the 2600 Duo, they're pretty much the same camera, by adjusting that silver screw on the side. You'll either turn it one way or the other to get the stars as small as possible. The main problem that I'm having though is that the stars are almost too dim to see. So with that in mind, we have the go-to functionality. We could always back out of the auto guider menu, go back to the sky atlas, and then just find a bright star that you can actually see somewhere overhead. Then tell the mount to go to that star. You don't have to do this step, but I'm just trying to give you ideas that can help you if you're having a hard time seeing the stars with your auto guider. In my case, I can see the stars of the Big Dipper quite well. Any one of those would work fine. I'll just pick maybe this one here. I'll hit go to, head back to the preview window. There we can see that Big Dipper star. That should be a lot easier to focus on. So I'll click on the guide button, click on the guiding graph, click on the begin looping arrows if I need to, and then I could try adjusting again that silver screw on my camera, or if you have a traditional guide scope, you'll want to focus that instead. Of course, if you're still having trouble seeing things, you can always increase the gain of the guider camera. I should have mentioned this earlier, but I just forgot. I like to use a higher gain whenever possible just to make sure I can see the stars, because if the gain is too low, you're not going to see as many stars as you should. If you're still having trouble seeing the stars, you could turn on the switch for Guide Camera Bin 2. That'll make the guide camera more sensitive to light, but it also lowers the resolution. So I would only use this setting if you're shooting with a narrowband filter and one of the Duo cameras, which has the auto guider sensor next to the main camera sensor. Unfortunately, I'm still having trouble focusing on the stars. And the main problem is that in this guide interface, you can't zoom in, which is kind of dumb. So I've got one final trick that can help you out. I know we're going down a rabbit hole here, but I want to be as thorough as possible because I know a lot of people run into problems. Again, this is entirely optional, but what you could do is go to your guide settings, turn off the switch for your guide camera, go to the main camera settings, turn off the switch for your main camera, and then you're actually going to select your auto guider camera as the main camera, then turn on the switch. This allows us to use that main preview interface with the ability to zoom in with our guide camera, which should make it much easier to find those bright stars and focus in on them. So I'll head back to the main preview window. Now that we're actually using our guide camera to see, I'll take a 3-second long test photo, and then I'll adjust that silver screw on the side of the 2600 Air. That shifts the focus of the auto guider sensor. Just make a note of the direction you're turning it. That way, if things look worse, you know to go in the opposite direction. This will take you a few minutes just to figure things out and get the stars as small as possible. So I'll let you do that, but when you're finished, we have to remember to switch our cameras back to normal. So we go back up to the main camera settings, turn off the switch, select our actual main camera as the main camera and turn it on. Then we go to our guide settings, grab our guiding camera and turn it on. You get the idea. All right, finally, we can begin the guiding. This was supposed to be simple, but this is actually my first time using this 2600 Air, and the guider sensor wasn't properly focused, so we had to do some additional steps. The good thing is though, once you have your auto guider focused, it should stay consistent from night to night, for the most part anyway. I almost forgot, but we're actually still aimed up towards the Big Dipper. So I'm going to go back to the Sky Atlas for the 3rd or 4th time tonight. And rather than doing the Elephant's Trunk Nebula, I think I'll do the North America Nebula instead. That's a big, bright, easy target. If you're feeling a bit overwhelmed and confused, I apologize, but I wanted to give you a realistic idea of how the night goes, so we're encountering all the problems together. If you want a more concise workflow, I do have some older videos where we just go step by step without necessarily all the different problems that we've encountered tonight. Okay, finally, we're back on track. So we'll go to the guiding interface, begin looping, and then all you have to do normally is click on the begin guiding crosshair. It will automatically select a bunch of stars that it likes and begin the calibration. You have to do this calibration every single night before you begin taking photos. but the whole process is automated and it shouldn't take more than about 5 minutes to complete. If you get a warning message though that says you're too close to the North Celestial Pole, something along those lines, that means the target you're photographing is too close towards Polaris. And because the stars don't really move as much up in that region of the sky, it can't do a calibration. In other words, you want to go back to the sky atlas again, aim towards a random portion of the sky towards the east or the west, then begin your guiding calibration. And the cool thing is with the AM5 and the ASIAir, once you're calibrated, you can aim at any target you want, and there won't be an issue. Thankfully, we don't have that problem today, so we're looking good. When the calibration completes, the line will turn green, and then the graph will appear. You'll then see a red line and a blue line. The blue line corresponds to your right ascension axis, the red line to your declination. And what you're looking for is a flat line right through the center, ideally. The more those red and blue lines are going up and down, the worse you're guiding, and the worse tracking results you'll see. But in fact, the AM5N has fantastic guiding capabilities, as we're seeing here. It's actually the best I've ever seen for me personally. That means I can easily shoot 5-minute long exposures, if not maybe even 10 minutes, if I'm feeling lucky. In any event, we've got the guiding up and running, we can back out of the guiding interface, and now we're on to step number 5, ready to take our photos. To do this, we'll change from Preview to AutoRun. And inside of the AutoRun menu, we'll click on the 3 dots and 3 lines to access the shooting schedule. I'd recommend starting off by changing that target name to something you're familiar with, because this will be embedded in the folder name and potentially the file name as well. So I'm going to call this North America for the North American Nebula. That makes sense to me anyway. If you scroll down on that left-hand menu, you can turn off the ASIAir at the end of the shooting schedule, and you can even tell it to go back to the home position if you want to. It's not a bad idea, especially if you're just doing one target for the night. Next, we'll click on that big plus button to add our first shooting schedule. This is where you can determine if you want to do lights, flats, bias, or darks, but we're just focused on light frames for tonight. I like to shoot 5-minute long exposures, so I'll put this to 300 seconds. That gives me a lot of light, especially when I'm shooting in narrowband. Then I'll set the gain to 100. That's usually the default gain for many ZWO cameras. You want to do your own research though to find the best gain. Finally, we have the repeat. This is how many photos you want to take. I'll probably just do like 40 for tonight. And once you enter all this information and click OK, at the bottom of the screen, you can actually see how long things will take. It's estimating about 3 hours and 24 minutes to complete. However, the meridian occurs at 2 hours 27 minutes from now. And when the meridian flip occurs, the AM5 will automatically move your telescope from one side of the mount to the other. So you have to watch out for that. That is a potential problem. So you always want to be aware of when the meridian is, because this could be problematic if you have long cables that might get snagged. Thankfully, we've got the AM5N though, and that should seriously reduce, if not entirely eliminate, the chance of getting cables ripped out. Therefore, I'm not really going to be worrying about the meridian too much tonight. And the final step is to click on the circular button. That will begin the shooting process. Well, we finally made it. We've completed step number 5, and we're taking our photos. While this is running, you could always inspect your guiding graph up close and just get an idea of how things are going. And I gotta say, I've never seen a declination error this low before, so that's very impressive from the AM5N. That seems to be the consensus with everybody reviewing this mount. They're all blown away by the guiding performance, especially compared to the original AM5. I'm gonna go take a quick break while this photo is being captured, and then when that's done, we'll take a look at it together and see if we can notice any problems with it. Okay, welcome back. I actually switched over to my iPad in the meantime because my phone battery is getting low. And what I want to do now is just zoom into the photo and verify the stars are actually sharp. If I'm seeing star trails, that tells me that maybe my exposure is too long and I'd want to shorten it. Or if the stars look a bit soft and fuzzy, more than likely my focus has shifted as the ambient air temperature cooled. If you decide that your stars are also a bit soft, then what you would want to do is pause the AutoRun, change back to the preview interface, attach your Badnov mask, and take some more quick test photos to refocus the telescope. You might also decide that your composition isn't as good as you thought. In that case, you would also want to stop the AutoRun, go back to the preview window, go to the Sky Atlas, and then just adjust your composition slightly. I do this all the time. With your new composition looking better, we'll return to the AutoRun menu. You might want to reset your progress so you don't get the old images and the new images mixed up, and then we'll begin our new shooting schedule. My final bit of advice is to watch things closely. Every 5 or 10 minutes, I'll look at my iPad, I'll zoom into the stars, and I'll just verify that they're sharp. If I notice they're getting softer, then I'll head outside and refocus. And that's all I've got for you in today's video. I've shown you the full process from setting up the mount initially to actually taking your first images. If you want to learn even more about astrophotography, then check out my Deep Space course. There's over 80 videos that take you through the entire process with a heavy focus on editing, because that's really where you have the biggest impact on your final image. All right, well, that's all I've got for you. So thanks for watching. I hope you have a clear night, and I'll see you guys in another video.